much. Thank you again for the opportunity allowing me to speak JCON online. This is my first JCON conference. Without further ado, let's get started. So, a bit about myself. I am Fabio Turizo. I work as service manager at Payara Services Limited. I live in Colombia, across the Atlantic, on the beautiful and sunny city of Barranquilla. But I have worked with Payara, which is an European company, for more than 7 years. And I think that this is the first time that I've spoken at a European conference, because usually I do American and South American conferences, both online and in person. But this is, I think, my first European event. I'm excited to be here. So a bit about promotion about Payara. If you are not aware, Payara Services is the company that we are strategic members of the Eclipse Foundation. And we contribute to both the Eclipse Microprofile Working Group and the project management of the Jakarta community. So if you're familiar with these technologies, which are, in a sense, cross-platform technologies that are buying to the official standards in the Java ecosystem, then we heavily contribute to the development and management of them in behalf of our customers and on the community and the users of our platform. So we do have two main products. One is Payara Enterprise, which is a fully commercial build of the Payara platform. It's focused on stability with a 10-year life cycle. The idea is that we handle specialized support for any of our customers that have those particular concerns. So if they want some reassurance on how to run their environments to scale on either a cloud or on premises or any type of hybrid environment. And we also have a community counterpart offering that it's focused for the development and innovation. We want our users to start testing stuff as soon as it is available, especially because we implement these technologies that I mentioned. We are mainly interested in hearing back what the community has to say about the features that we have implemented, about the technical baggage that the product carries. So if any of you are interested, Community Edition is fully free. It has no strings attached. You can use it in any of your projects, and we encourage our users to start, playing around with it and share any feedback if they have to. So finally, the Payara Platform Enterprise, which is our aggressively compatible cloud-native environment. It is an implementation of both Jakarta and Microprofile. It is container-friendly. If you are heavily using Docker and Kubernetes or provisioning your cloud infrastructure with those technologies, then you should have no problem running Payara in most of the popular and marketable cloud environments like AWS, Azure, Google Cloud Platform, Oracle, etc. And yes, as I mentioned, we have a 10-year support lifecycle. At the moment, we have 3 main versions, 4, 5, and 6. We are supporting Java 8, 11, and 17. And during I think that at the end of the month, we're introducing a release that will be compatible fully with Java 21 on both versions 5 and 6. So we are trying to catch up with everything Java related, trying to stay on the race and making sure that our customers that acquire products are covered through this long period so that they don't have to worry about constant upgrades and migrations. Okay, so the sales pitch is over. Thank you. Let's get started with the talk. Why talk about OpenID? The first question is, to those who are not aware, what is OpenID? Well, OpenID is an open source standard solution that is focused on 2 main things. The centralization of account management. That means that if you work on an organization that has an ecosystem of applications, you're probably worried about, okay, maybe an application manage users on a NoSQL database with no encryption or basic security measures. Maybe another application stores user identity on files or on encrypted disks that lives on a computer somewhere. And as a manager and operations of that company, you're probably losing sleep on, okay, there are many points of failure and user data is spread all around the place. There is a lot of vulnerable points that you need to address. So in that case, you also have to worry about what happens when you have to share user profiles, because again, we live now on a year and age that it has encouraged heavily to IT operations staffs all around the place to reconsider how user identity is protected. Not only about regulations, or probably those of you are aware about GDPR or General Data User Protection Acts all around the world, they have to consider, okay, how this data is shared in not only concise and secure, but also in an easy way, because the intention is that this is regarding operations and transactions that have to be performed. So a solution for this is OpenID, which is a standard, an open source standard. Anyone can see the implementation and anyone can take it and implement or use any OpenID provider around what the market has to offer. If they are not happy with the current provider, they can just simply switch to one that offers either better services or a better performance throughput, or maybe they offer better features, or maybe they are just simply unhappy with how the data is managed, because again, as a security solution, OpenID providers also have to self-regulate heavily in order to prevent data breaches. So as a user, you need only to choose an identity provider, and then you're good to go. That provider will become the custodian of your information, and you will interact with it with a standard way of communication. It is fully open source, decentralized. No one owns OpenID. Anyone can just simply start contributing to it. Frees the applications and websites of the burdens of account management. As I mentioned, instead of creating an application and creating a module for managing users and storing the users on a table, on a SQL or NoSQL database, structure, or whatever you want, you don't need to worry about that. Account management will be handled by the OpenID provider. And you can control how these profiles are shared and which applications have access to those profiles. You can say, oh, this is a specific application, which is a finance application or a finance-focused application, may have access to a specific pieces of data that other applications will not have access to. Or you can just simply open profiles to other services that will interact with even other account providers or identity providers in order to safely exchange data. And finally, you can give users control and consent of their data. If a user is not happy with how the data is being stored on an application, then they can control, okay, I will allow applications to access my data when they need to, only when I give consent. And that consent is structured around the idea of, well, regulating what applications and what the specific permissions these applications have in order to access that data. Popular identity providers nowadays, well, you have these four: Google, Microsoft, Apple, and Meta, or big companies on the technology space have implemented identity providers, and they have their own solutions. You can integrate applications by using these as third-party OpenID providers in a sense. But for example, if you heavily use Microsoft ecosystem and you have heard about Azure Active Directory, that's an implementation of OpenID that you can use. And many companies heavily that use the vanilla and traditional Active Directory have migrated to Azure Active Directory because it is OpenID compatible. And that migration makes applications easier to convert in a sense. So what about the Java space? So this talk is focused around the Jakarta specification, which I won't go into detail about that. If you're familiar with it, Jakarta is what was formerly known as Java Enterprise Edition. It was the de facto specification on the Java for making enterprise and business focused applications. Sadly, through the years, it was losing ground to all the frameworks, and the owner of this technology, which was Oracle, was not heavily interested in developing it. So at the end, it decided to donate the entire technology to the community. It did not donate the trademark, so it had to be branded from Java to Jakarta. So it is something of a, let's say, big history that I'm just giving a quick summary into. But if any of you have been developing applications on Jakarta, or if you are aware of the technology, you know that one of the main problems is that the security aspects of the technology were not centralized on an API or a specification that simply told users, okay, you want to secure your applications, this is what you do. Java EE did not have that. It allowed vendors, in that case, any implementer of technology, to decide, okay, if you want to implement security, this is how you proceed. It was a mess and it was chaotic in a sense because every vendor did what they wanted. There was no centralized or intuitive way to do it. no proper standards, actually. So there were a lot of reinventing the wheel. I have seen through the years many users who said, oh, I implemented this application on WebLogic or on Glassfish, and in order to integrate to this LDAP server that contains all of my user information, this is what I wrote, and they probably wrote an extension or an authentication module or something that doesn't translate to other technologies or to other vendor software. So that kind of repurposing of that technology proprietary, let's say, module definitions were difficult. So until Jakarta security, which was introduced in Java E8 prior to the transformation to Jakarta E, was a proper way to do that. So Jakarta security basically said, okay, let's consolidate everything security related, specifically web-based security, on one specification. And this is how we tell users how to secure their applications. Because that gives the users the intended way to use the API and gives them proper guidance on how they need to implement this. Sadly, it's still not perfect. It lacks some proper features way beyond what is the basic authentication. OpenID was one of these features that was implemented just recently. Before that, if you wanted to integrate with OpenID, you had to code the entire module yourself. Nowadays, you don't need to. You just simply need to integrate using the standard mechanisms that I'll showcase. Jakarta security uses a simplified security model. It's well-oriented. If you come from developing really old legacy applications that depended on remoting, or integrating with remote technologies, or using heavily web services or XML-based web services. I'm sorry, but this technology is not for securing this. This is just for securing HTTP control or HTTP focused technologies that run on a web container that runs either servlet or Java Server Spaces or Jakarta REST services or even WebSockets. But beyond that, if you need to integrate Jakarta security, unfortunately, there are no standard mechanisms. You could implement modules, but that's not the intended way. So it is focused around two main concepts, the authentication mechanism and the identity store. So the authentication mechanism or HTTP authentication mechanism is the one that tells Jakarta security how to connect an application to an external provider that will validate the request. That request may contain the user credentials, it may contain a token, it may contain a certificate, whatever. And in the case of OpenIDConnect support, the state is usually stored in HTTP session cookies. So in this sense, if you are heavily intended to use OpenID in both Jakarta or even beyond the Java world, you need to heavily rely on HTTP session cookies. Additionally, there is a concept called identity store that tells the application, okay, you have authenticated your user. Where do you go to look for that authentication? And the authentication mechanism delegates that search of the user identity to the identity store. By definition, OpenIDConnect doesn't include one or doesn't let you configure one because it introduces a mandatory identity store, which is the provider where the information will live. So OpenIDConnect is the specific protocol of how authentication is done. It's based on the old OAuth2, which was a Google technology. Well, it was originally a Google technology, was then created as a formal standard, as a specification RFC. It was focused around signing flows. That means, oh, I need to authenticate against an application or a service. Then you need to follow a flow on how the data is exchanged across services and actors on the business logic, in a sense. It was heavily extensible, which is what allowed OpenIDConnect to be created. And the idea of OpenIDConnect is that you have specific suites on the protocol that anyone can implement. At the moment, let's say that the most complete one includes 5 products or 5 protocol suites, in a sense: core, discovery, client registration, session management, and 4 response mode. If you want to integrate with very basic use cases, core is more than enough. And OpenIDConnect platforms, again, as I mentioned, there are providers. The platforms are any provider that also implements OpenIDConnect. If you want to rely on a third-party service, then you could use either Auth0 or Okta, which are services on the web that you can contract to, and they will give you accounts and they will give you specific tiers where you can store your users' information and integrate your applications. I am other representatives of these companies. They have their own flaws, and as any other company online or a company on 2023, they also have their let's say, blunders every now and then. So if you are not interested in trusting a company, you can also implement your OpenIDConnect provider on premises. There are products to do that. One of them, which is highly popular, is Keycloak. In fact, I have a keynote talk like this one that runs all of this on Keycloak. Or if you are familiar with the Java ecosystem and the awesome ecosystem identity platform products, then there's ForgeRock that inherited all of that from them. So OpenID authorization is very simple. Data is exchanged through tokens. Like most of the technologies nowadays, there is an access token that tells the application, okay, I have authenticated an user. There is this access token that will grant that user access to any service or application that he is authorized to access. And if the user or if the application needs to know, okay, I know that this user has access, but I need the information of this user, then that data is exchanged on an identity token. And the identity token, it's formally a JSON web token. This is an official open standard as well. This is part of an specification. And the tokens have expiration date, because the idea is that they should be short-lived. When the access token expires, the user needs to get another one. And in order to do that quickly, there is the concept of the refresh token that allows you to get access to it immediately without the need to re-authenticate. There are 4 basic types of grants. I won't go into detail, but this is what basically OAuth2 handles. The OpenIDConnect standard, it's mainly focused around the first grant, which is the authorization grant. And the process is very simple. The end user navigates to a website. They click on the sign in button. They type the username and password or whatever credentials the OpenIDConnect provider allows you. They get authenticated and get authorized. The OpenID provider then will give you an identity token and usually an access token. Some OpenID provider flows allows you to ask for those separately, but the authorization grant in general will give you access to both at the same time. Then the reliant party, and the reliant party in this case is usually the application, will resend or redirect the user to whatever application that we're trying to access. And if at any point the application needs to access the information of the user, they can call a user info endpoint. That is basically the name of the endpoint. It is a standard name that will give claims or serialized data of what the user information is. A more, let's say, flow approach of this would be like this. The user initiates the authentication. The request goes from the reliant party to the provider. The provider authenticates the user. Then the authorization flow actually gives an authorization code. That authorization code is given back to the reliant party in order to safely exchange the token. Because again, this has to be done in the most secure way possible. And in order to prevent man-of-the-middle attacks, then this is something that you can do. At the end, you will call and retrieve all of the user information using the user info endpoint. So how do you do all of this on the actual Java code? So as we're talking about Jakarta, and as I mentioned, there are authentication mechanisms on Jakarta security. The annotation OpenID authentication mechanism definition, I know is a lot to say, but this contains all of the configuration that you have to tell your application where is your OpenID provider located. You have to provide several data, the client ID and client secret. These are basically a staple of OpenIDConnect. Client ID is an identifier that the OpenIDConnect provider identifies your application or service. And a secret is usually a key that is only known by the provider and the application in this case, and they exchange that key in secret. Then the redirect URI is needed because once the authentication is done successfully by the OpenIDConnect provider, it will redirect the web flow, in this case, the browser window, from their login pages or authentication views to the application that was doing on this behalf. Or sometimes, in the case of single sign-on flows, maybe the application needs to redirect to another portal or application in general because it was a gateway. So that is done. How does the application know where the OpenID configuration lives? Well, you need to provide a URI where the provided configuration lives, and it is a standard. This URI is usually on the provider's website, and usually by provider website, I would mean that your specific tenant on that provider, and then you will point to the well-known OpenID configuration endpoint. This is a part of the standard as well. Anything else is just additional configuration that you can do. In fact, the OpenID authentication also allows you to define logout behavior. If you want to log out, you can tell the application, okay, if in the case of a logout, safely redirect me to a web page of my choosing. And in here, for this example, I'm using the same page. You annotate this on any CDI bin under the application's code. In this case, I'm just choosing a singleton called OpenIDConnect configuration. It has nothing. It's just a marker class in order to anchor the annotation in a sense. So the annotation also supports dynamic behavior. What happens if any of these values are known at runtime because they are configured? Either, if, for example, you run your application on a Docker container, then this configuration will come from either environment variables, or if we're talking about Kubernetes, a secret directory, for example. So you can use expression language to point these values to a specific bin properties. In this case, I'm using a config bin that has a declare ID, the secret, the URI, and the scope. The scope expression is for designing what is the basic scope of which data you want to exchange on the authentication. So all of this will point out to specific bins, and on the code that I will going to show you, there is more details. So basic considerations on how to call this provider endpoint. You have to provide the authorization endpoint, the token endpoint, the JWTIS URI, issuer of the tokens, subject types, response times, and ID token signing algorithms. The fun thing is that even all of this is required. The implementation of OpenID on Jakarta, it doesn't require you to do this. All of this is done automatically because this data is exchanged by the provider and the runtime whenever they establish communication. The only thing that you need to do is just simply tell the runtime through this property, where is your provider's configuration? And they will exchange all of this automatically. There is also conditional metadata that you can exchange, a nonce value, in order to prevent man-in-the-middle attacks or prevent requisite forgery if you want to, a display value of what your application is presenting itself as, a prompt value that tells the authentication flow, okay, I want the user to log in or give consent, or if in the case that there are multiple accounts, because providers can handle multiple accounts per user, allow them to select which account they want to use to log into the application and any extra configuration. So finally, the runtime must do some validations because the token can come from anywhere. And what happens, for example, if someone hijacks the token? So technically, you need to validate that the token comes from an issuer. In this case, that would be the provider. A subject contains a value, and the subject is the user that you're authenticating. And some additional validations, specifically that the token has an expire, that is currently in the present, and it hasn't been issued in the past, and is no longer valid. And in the case of an audience, which I won't go into detail, an audience is a specific concept that OpenID manages for authorized parties, then the audience is present as well. Tokens must also contain rules and groups, because again, all of this is about authentication. Authorization is also taken into account. So in that case, the token that you define must also contain which roles or groups does your user belong to. I'm using those names exchangeably because by definition, Jakarta treats roles differently as groups, but the OpenIDConnect implementation treats those technically exchangeably. You can use groups or roles. For the specification, the term roles is preferred, and groups is preferred for groups of users, while roles is preferred for specific permissions or authorization capabilities or in the software or the application itself. So just to simplify the conversation, I'll be referring to groups. They can be supplied by the OpenIDConnect provider or the application. The idea is that they are provided by additional extra claims, and you can configure your application, in this case, to tell the OpenID runtime, in this case, Payara, which is what I'm going to be using, where do those groups come? And in this case, I'm using this custom groups claim on this annotation, using the claims definition that tells the runtime, okay, when you get the access token back from the provider, your groups will live on this specific claim. This is done because group definition is not perfectly standardized yet in OpenID. Some providers will use the actual groups claim. Others will use a special or allow the configuration of a special claim under a namespace, like Auth0, which is the one I'm going to use. Finally, because this is Jakarta and it still has some technical baggage, you need to tell your application, okay, what are the protected resources? And there are many ways to do this, but the easiest way for, let's say, REST application or a REST microservice is to use the web.xml deployment description and tell, okay, these are the routes or paths of my application that are protected. Once you define these, the application will know if you try to access these resources, it will trigger the authentication process. Okay, so let's talk about the demo. It is on my personal GitHub account on the conference demo. If you go there, please take into account that all of the code I'm going to show you is on the Jakarta 10 update branch. The main branch is still quite outdated in a sense. So let me go and switch quickly here to presentation view on IntelliJ. Okay, so the demo, it's a very simple multi-project application that contains 4 applications. This is composed as a set of microservices and a UI dashboard that integrates these microservices. The dashboard is the one that is configured to integrate using OpenIDConnect because it is the entry point. Again, this is not a production scenario whatsoever. This is just a simple showcase of what you can do. The services are, and again, this is a service that or a demo that will run for multiple talks. It is a conference management application. You have 3 microservices, session, speaker, and both. One handles sessions, one handles speakers, and another handles both ratings for sessions. I will only be using these 2. This one is at the moment irrelevant. Every service is configured as a Jakarta application. It uses, for example, Jakarta persistent entities for storing data on a database. And as you can see, all of these are simple staples of how the data is integrated. It has Jakarta REST services for interacting with the data. And in fact, in here, you can see that I'm also using microprofile OpenAPI in order to configure our OpenAPI documentation for these paths. But again, those are extras. The session service, it's also configured in the same way. It is a very simple service that contains also an API, session resource, that allows you to create sessions and retrieve the data of sessions, delete sessions, etc. And it also contains a session entity that is defined as Jakarta persistent entity as well. These microservices are called from the dashboard application. And the dashboard application is a really simple Jakarta faces application. You can see that I have defined some Jakarta server faces or Jakarta faces web pages in here. They are composed and integrated using facelets. And let me quickly show you here. This is my main template. It contains prime faces components because prime faces is very powerful and allows you to define quickly applications with a lot of simplicity. Let's say that. So how do I configure my authentication on this application? Well, let's go to this security package. And in here, I have the OpenID security configuration. So again, I'm using the OpenID authentication mechanism definition. I'm pointing a client ID, a secret, redirect URI, a scope. Again, the scope is not needed. By default, it will assume OpenID and profile. In this case, the OpenID authentication provider that I'm using for this example, which is Auth0, this is a service owned by a company called Okta, allows you to define an offline access scope. This allows you to retrieve offline tokens if you want to access your information while the application is not allowed to connect to the OpenIDConnect provider. This can happen if in the case the application gets offline during a set period of time. It is a recommended practice if you need to. The prompt is configured to log in. Each time that you access the application, you will have to log in the first time. You can not use this and allow the application to remember logins across accesses to subsequent accesses to the application. The provider URI comes also from a specific Bean configuration. I'm configuring my groups as well using claims definition. I'm configuring an audience. I need that in order to integrate Auth0 with the OpenID authentication. Otherwise, it will get rejected, my token, because the audience has to be validated as well. And finally, I'm also configuring logout behavior. Now, and here I cheated a bit. All of the configuration is extracted from this same bin, OpenID security configuration. This is defined as a singleton CDI bin with this name, which is why I can access it like this. And the variables are extracted using microprofile configuration. This means that this is extracted from either environment variables or system properties, or in the case of this example, I am using a really simple properties file where all of my data is. So here is my client secret, here is my namespace, here is my URL, etc. All of the data is accessible in here, and you can see the ID as well. Okay, so let's actually run this, and while it's running, let me quickly show you how do I configure this on my provider. So let me run the session service, then the speaker service that can run in any order, and my dashboards application. So while this is running, here is my Auth0 dashboard. I am using a dashboard for, account named Payara. And in this account, I have defined my application. In this case, the application that I was showing you. Just this one, Payara Conference Demo GSF application. If I go in here, you will see that it contains the same client ID, like this one, this client ID. So this corresponds to the data of the application that will connect in behalf of my users. How Auth0 allows me to configure this? There are two main configurations that you have to do. Number one, you have to configure application URLs, and in this case, allow callback URLs and allow logout URLs. And you have to point out to this specific URLs in order to allow the application to be authenticated. Otherwise, the authentication process will be rejected. That's it. You have to do this both the callback and logout. The callback points out to exactly the redirect URI that I was showing earlier. Now, on Auth0, I have a database of users. And in user management, you can see this. Oh, there are these two users, a user called Michael Alpha and a user called Carol Bita. They have username password authentication. Auth0 allows me to integrate users with other external providers. Maybe I could use a social login through Meta or Google or Reddit or whatever, or another social media you would choose. In this case, I'm just using standard username and password authentication. And the roles as well. You can see that I have 3 roles, an admin role, an attendee role, and a speaker role. And in this case, I have configured these roles for my users as well. So if I go to the admin role, you can see that the Carol Bita user actually is assigned to this role as well. And this role will automatically get converted to a group. Okay, so my application should be running. Excellent. So let's go and open the dashboard. Thank you. So localhost 8080 dashboard. Okay, and this is a very simple landing page, nothing special to talk about it. If I click sign in, you'll see that I will be redirected to my Auth0 OpenIDConnect login webpage. So in this case, you can see that the request is done in this case and state is sent. And probably once I click continue, because again, all of this will be quickly done in succession, and authorization code will be exchanged between the provider and my runtime, and then it will redirect me back once I have the access token. So in this case, see that I can authenticate here. I will go and authenticate using this user, Michael Alpha. I'll click continue. And I'm redirected as Michael Alpha. I'm accessing this information. Again, the only thing that I have for the moment for that user is the email address. But now I have access to these tabs on the application because this user is allowed to do some things. Not all of them. This user, let's see if we could try to create a speaker. Let's try to create myself as a speaker for OpenIDConnect talk, for example. Let's click save. Yes, and I can add a speaker. So this user allows or can add new speakers to the session as well. And if I go and try to access the sessions, let's see. See that I don't have access to anything. I cannot create new sessions. How's that? Well, this is a very simple and silly thing. On the interface for this application, I have created an auth controller. This is a CDI bin that allows access to a security context. This add inject security context is another one of the features of Jakarta security. This allows me quick access to know which is the user that is authenticated on the application. If I want more information, specifically identity information from OpenID, I also can use the OpenID context, which this annotation has more power. And sorry, this class has more power and it's like a superset of information that I can access to. So in order to know if the user is, let me actually hide this. Can I? Oh, okay, very well. So in order to know if the user is authenticated, I can just simply call security context get caller principal. And if this is not null, then I know that the user is authenticated. So I'm just simply wrapping this on an optional. To get the identity name, I can get it from the OpenID context. And in here, I can use the get claims method that will return me a set of valid claims and standard claims from OpenID. And one of those is the name claim, which will allow me to get the data for that name identity that the OpenIDConnect product is retrieving. In fact, what claims can you get? Well, you can get the file name, given name, middle name, address, birthday, email, verified email, gender, locale, nickname, etc. All of this information comes by default from the OpenIDConnect provider because it's on a standard staple. These claims have to be, and this data has to be defined by my provider. But because these are very basic users, I won't have access to that because I haven't provided that information. And how to know which features of my application this user has access to? I can use many things, but I prefer to use the standard is caller enroll method from the security context that allows me to know, oh, is this user a speaker or is this user an attendee? And that is simply done by verifying if they have access to this role as well. So the is caller enroll method will allow me to know if this user is a speaker or if the user is an attendee or if a user is an administrator, like this. To log in, what I do, I just simply call the security context authenticate method and redirect the request and the response. This is a bit of a hacky piece of code that I have to do on Java Faces, or on Jakarta Faces web page in order to redirect the web flow from one application to the other. But just doing this will trigger the authentication. I don't have to do anything else. The logout, it's pretty simple. To just do the logout, I have to grab the request and call .logout and tell the Faces context that the response is complete and the redirection will be taken care of by the authentication, or in this case, the OpenIDConnect provider. So if I go back in here, oh, right, I was going to show you the web page. So the web page, very simple. Respond here. So the web page is, in this case, sessions, for example, has this, hide this and hide this. You can see this clearly. So you can see the web page has a button in here somewhere, this one, that allows me to create new sessions. And this button is only rendered if the user has an admin role. So only admins can create new sessions. And in order to quickly test this, I can just simply go back to my application, log out, log in again, and switch to my administrator user, which is Carol Bita, hit continue, log in and see that, okay, now I have access to this feature and can create a new session. Let's, for example, call the session effective microservices on a specific venue, on a specific date. It will last 1 hour and Fabio Turizo will be speaking. Hit save and the data has been created because the user has access to that. So authentication is very simple. See that nowhere in my application, I have code that is handling these users or is handling the information or is handling how this identity is created. It's just simply retrieving them very quickly from the OpenIDConnect provider. Very, very simple demonstration. So while I have some time, Fire Cloud is a new product that we are launching. It allows you to run Jakarta applications on the cloud very quickly. And I can just simply quickly how it is. If, for example, I want to run the same demonstration on Fire Cloud, the only thing that you have to do is to provision your WAR file, or in this case, the artifact that you want to deploy, click deploy on the admin console, or you can also use the command line interface utilities from Paya Cloud and deploy those from whatever continuous integration environment or local development machine you want to. And you can deploy your applications and integrate them quite quickly. So a way to do that is that you go to the Paya Cloud browser, in this case, like this one. This is the dashboard for Paya Cloud. You create a namespace or a universe of data. And in this namespace, you can just simply deploy the same applications that I was showing. So in order to do this, you upload an application. Let me browse it, go to the conference demo. Let me grab the speaker service WAR file. This one is a really small WAR file. Click deploy immediately, give it a name. So in this case, Microservice speaker, and upload. And while this is deploying, I can also go and deploy another separate application. Let's upload it. The dashboard, in this case, conference demo, dashboard, target, QA dashboard. I don't want to deploy this one immediately because I want this to be configured before. So dashboard, let's upload this. Okay, let's see. My microservice speaker is running. You can see that it's running on this URL. Let me grab this link because I need this microservice in order to configure my other application. So I will edit the configuration. You can see that it's running on Jakarta Paya 6, JDK 17. You can choose what is the runtime that you want to use. Through this demo, I have been running using Paya Micro, which is a Jakarta standard compatible environment. And apologies if I did not show that, but that is easily seen in here. My dependencies are Jakarta, micro profile, and I'm also using some of these applications, Java Cache, the Java standard caching API. And the runtime that I'm using is Paya Micro 6.2023.11, which is the current version that we just released last month. So, okay, back to my application. In order to configure this, you can see that, hey, here is my ID, here is my secret. Again, I can share this with a really small application that will immediately kill after. And my microservices have to be configured because otherwise, see that they are pointing to my local ones. This is coming from the file that I pointed out. So I will just simply create this, save, good, click deploy changes. And if everything is running correctly, then I should be seeing that super quickly. Deploy it. Okay, so let's actually open the dashboard. And that should be, okay, the application is still deploying. So let's give it a few more seconds. Dashboard, deploy. All right, so it was deployed. It's deployed like this, sadly. Okay, and the application is running. So if I want to sign in, right, because it was deployed with dashboard with Opera D, then it won't match the callback URL. Okay, small mistake, but it showcases how all of this is secure. Because if I wanted to authenticate this application or to authorize this application, I will have to go back to the application configuration here on Auth0 and just configure that URL in here. Because at the moment it's doing a very basic. Actually, let's see if I can quickly do this and cheat it. It will be dashboard. Case. Let's hit save. Save changes and see if it actually allows me to play nice. Now, unfortunately, I was not. But okay, close there. So on the 2 minutes, I could just simply run that really simple application on Paya Cloud. Could deploy it, I could showcase it. So if you're interested, we are running a free trial, 15-day free trial that you can use Paya Cloud in order to deploy Jakarta applications. Very simple, small WAR files, so complex microservices arrangements on Paya Cloud. You can choose runtimes and configure the resources up to your liking as well. So that's it. Thank you so much. I don't know if there are any big questions or anyone from the audience have a question particular.